So I know a lot of you guys asked for me to put up a video, so I'm going to go quickly through the Chapter R practice test, and just please know that tomorrow there's going to be a couple more questions on here than this. We do have an A schedule, which is a little longer, so you'll have plenty of time to finish this. Okay, first off, inequalities. You'll always have two solutions, so this is a less than, so that's x minus 5 is less than or equal to 4, which is greater than or equal to negative 4. Add 5 to both sides. We have x is less than or equal to 9, or x is less than or equal to 1. Likewise, we have a greater than sign, so that's greater, so x minus 4 is greater than 2, or x minus 4 is less than negative 2. Change the sign, change the inequality, so then we add, we get x is greater than 6, or x is less than 2. Alright, so there's our first one. Next up, find the radius of a circle with the center passes through this point. So we have x minus h squared plus y minus k squared equals r squared. So we plug that in, we get, we're going to plug in this point in for x and y, so that's 2 squared plus 2 minus 1 squared equals r squared. 2 minus 1 is 1, so this is 4 plus 1 equals r squared. R squared equals 5. And I don't really need to know what the radius is, because find the radius of the circle. Oh, so we take the square root, r equals square root of 5. And since this is a distance, it's always going to be positive. So, 2. Is the function even, odd, or neither? For it to be even, f of negative x would be the same as f of x. For it to be odd, f of negative x would be the same as negative f of x. So let's just plug that in and see what we get. So if I plug in negative x, I get negative x cubed minus x plus 1. That's not the same as the original, so it's not even. If I make it negative, then that's negative x cubed minus x minus 1. And that's not the same either, so this is neither, or neither. Okay, next up, find the interval over which the function 1 over x plus 2 is increasing. So we should be able to look at that and see that this x plus 2 here gives us a shift to the left. And that absolute value is changing our graph by wherever it's negative, it's positive. So I'm going to sketch it. Here's 1 over x plus 2. 1 over x plus 2 is over 1, 2, and it's like this. Because of the absolute value, all negative values become positive. So our new graph would look like this. And now I'm looking for where this is increasing. So from negative infinity all the way up to negative 2, that's my increasing interval. Next up, find the domain and the range of the following function. Well, we know we can't divide by 0, and square roots can't be negative. Because of those two, I'm going to take what's underneath the square root sign, set that greater than 0. It can't be 0, and I want it to be larger than that because I want positive numbers out. So that leaves me with x squared is greater than 2. Take the square root, which leaves me with x is greater than 2, or x is less than negative 2. So that's my domain. My range, so that's my domain. My range, well, degree of the top is 0. Degree of the bottom is technically, when we get really large, it's just going to be 1. So that means we have a vertical asymptote at 0, so y cannot be equal to 0. There's my range, because we have a horizontal asymptote there. 6. Find the equation of the line perpendicular. So first, let's do a different color. We want to get y by itself, so that's 2y equals negative x plus 1. So y equals negative 1/2 x plus 1/2. So my slope there is negative 1/2. My perpendicular slope would be 2. So now I'm trying to write the equation of the line. I use point slope form, so y minus 1 equals 2 times x minus a negative 2. Last problem on this page. So calculate the composition of the function and determine its domain. So if I want f of g of x, I'm replacing x with x to the negative 1/3. So this is 5 over x to the negative third squared plus 2, which is 5 over x to the negative 6th plus 2. Now, if I look at this, I want to know, if I'm looking at the domain, what makes that 0? So x to the negative 6th plus 2 is not equal to 0. Well, x to the negative 6th equals negative 2, not equal to negative 2, which is the same thing as saying 1 over x to the 6th equals negative 2. This is not possible, and because I can't generate any negative numbers or any numbers that make this 0, my domain is all reals. Okay, for the second page, find the cosine, tangent, and sine if secant theta is equal to 2 and theta is acute, which means it's less than 90 and it's bigger than 0. Okay, so that tells me I'm in my first quadrant. The other thing is secant theta is 1 over cosine theta equals 2, or cosine theta equals 1/2. So if cosine theta is 1/2, that means opposite over hypotenuse. So this is side root 3. So we already know what cosine is. So then sine theta equals root 3 over 2. And tangent theta equals 1 over, oops, I wrote that backwards. Cosine is adjacent over hypotenuse. So that's root 3. Just changes those. This is still right, but then my tangent is going to be just square root of 3 over 1. That's what happens when you rush through these. Okay, number 9. Find the domain. Domain, what makes the denominator 0? So x is not equal to 3. 10. Compute cosine, inverse cosine of sine of 7 pi over 6. So 7 pi over 6. Sine of 7 pi over 6 is, let's see, sine would be y, so that would be 1/2, so it would be negative 1/2. So I want to know at what angle is inverse cosine negative 1/2. And that's going to be in the second quadrant. So second quadrant, where is, so if I do my little hand trick, then I'm going to be at 2 pi over 3. And hopefully we know our unit circle well enough to just do that pretty quickly. All right, 11. Find the inverse. So step 1, I'm going to switch my x's and y's. Step 2, solve for y. So I'm going to distribute, so that's 2x plus xy equals 4 minus y. Get the y's on the same time, get everything else on the other. So I have y plus xy equals 4 minus 2x. Factor out a y. 1 plus x, or x plus 1, equals 4 minus 2x. So then y equals 4 minus 2x over x plus 1. So that's my inverse. My domain would be x is not equal to negative 1. For my range, I look at the degrees, degree of 1 on top, degree of 1 on the bottom. They're the same, So I look at the coefficients, so that's why it's important we write that negative 2x plus 4 over x plus 1. So then my range is y is not equal to negative 2 over 1, or negative 2. 12. Calculate log of 8 of 32. How can I do this efficiently? Well, the easiest way I can think about it is 8 is a power of 2 and 32 is a power of 2. So I can do a change of base formula. So change of base, I want to change the base to 2. So that would be log base 2 of 32 over the log base 2 of 8. That's our change of base formula. 32 is 2 to the 5th. 8 is 2 to the 3rd. So this is really 3 log base 2, 5 log base 2 of 2 over 3 log base 2 of 2. Well, those are both just 1, so I'm left with 5 over 3. I hope you guys heard me in class, but we're just going to skip 13. It's going to save us some time. Okay, for 14, find all the vertical and horizontal asymptotes of the function. So you could use a calculator, but I hope you guys know how to find vertical asymptotes and horizontal asymptotes. Vertical asymptotes, we don't want the denominator equal to 0, and so I'm just going to quickly factor that. X plus 6, x minus 2. So x can't equal negative 6, and x can't equal 2. That's my domain. So my vertical asymptotes are going to be x equals negative 6 and x equals 2. Those are my vertical lines. For my horizontal asymptotes, degree of the top, 2. Degree of the bottom, 2. So that means that my vertical asymptote is going to be y equals 3 over 1, which is 3. 2 more. 15. Determine the value of tangent of inverse cosine of 1 over root 2. So inverse cosine, what angle am I 1 over square root of 2? So I could say that's my theta, or I could say cosine theta equals 1 over the square root of 2, which is the same thing as root 2 over 2, if I rationalize it. Okay, so if that's the case and cosine's positive, that means I'm in this first quadrant. So I'm going to draw my triangle, and that's root 2 over 2. So this is also square root of 2. No, doing the Pythagorean theorem really quickly. So I want to know what the tangent is. Well, whatever root 2 over root 2 is, which is 1. So tangent's 1. Last off, simplify the difference quotient. So wherever we see an x, and this is going to be the first little things of derivatives that we're going to see, we're going to plug in x plus 1. So I'm just going to find out what f of x plus h is equal to. So that's 2x plus h squared minus 4 times x plus h plus 3. I'm going to FOIL that out. So that's x squared plus 2xh plus h squared minus 4x minus 4h plus 3. So to expand this all out, that's 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 3. That's just that first part. So if I put it all together, let's use blue, it's 2x squared plus 4xh plus 2h squared minus 4x minus 4h plus 3 minus 2x squared. Change all of the signs. Minus 3 all over h. Now, if I look on top, I have some like terms. Negative 3, positive 3, positive 4x, negative 4x, negative 2x squared, positive 2x squared, leaving me only with 4xh plus 2h squared minus 4h all over h. I notice that all three of these have an h in it, so I'm going to factor that out. H parentheses 4x plus 2h minus 4 all over h. Those cancel, which leaves me with 4x plus 2h minus 4. And that's simplifying the difference quotient. Hopefully this video was some value to you guys. I hope to make one for each chapter practice test. All right, good luck tomorrow.